And now we have part 2 of our discussion on mirrors. In the previous video, we covered the flat or plane mirror. Let's now go over the curved mirror. There are two types of curved mirrors or spherical mirrors. We have concave mirror and convex mirror. First, let's go over the concave mirror. Concave mirror, also referred to as a converging mirror. You have the curved mirror. The inner curvature is the reflective side of the mirror. It's the surface that is facing the front of the mirror. The center point of the mirror's curvature is located in front of the mirror. Hence, the radius of curvature R is positive and the focal length of the mirror is also positive. So, R is positive and F is positive. Both the center point and the focal point of the mirror are in front of the mirror. Now, a concave mirror is also referred to as a converging mirror because the tendency of the mirror is to focus the light, particularly light that is parallel to the center line. You have the center line. Both the center point and the focal point of the mirror are lying on the center line. The tendency of the mirror is to focus any light ray that is parallel to the center line to focus that light ray towards the focal point. So, all light rays that are parallel to the center line will converge at the focal point. Thus, the mirror is referred to as a converging mirror. And again, any light ray parallel to the center line gets reflected towards the focal point. Any light ray directed at the focal point will become horizontal and parallel to the center line after it reflects off the curved mirror. And any light ray incident on the midpoint, the point on the mirror that is also on the center line, any light ray striking the midpoint of the mirror or incident on the midpoint of the mirror will be reflected according to the law of reflection. Angle of incidence, angle of reflection, they are equal. On the other hand, for the convex mirror, also known as a diverging mirror, the center point of the mirror's curvature is located behind the mirror. So, in front of the mirror, behind the mirror, the center point is behind the mirror. Thus, the radius of curvature R is negative. And since the focal length F is just equal to R over 2, since R is negative, the focal length is also negative, meaning the focal point is behind the mirror. R is negative, F is negative, you have a convex mirror or diverging mirror. Diverging mirror, say you have the center line, both the focal point and the center point of the mirror are on the center line. Any light ray that is parallel to the center line, when this light ray strikes the mirror, it gets reflected away from the focal point. So if you have several light rays that are parallel to the center line, those light rays will be reflected away from the focal point. Those light rays, the reflected light rays will diverge. Hence, we refer to the mirror as a diverging mirror. So, convex mirror or diverging mirror. And any light ray that is directed towards the focal point will become horizontal and parallel to the center line after it is reflected by the mirror. And any light ray incident on the midpoint of the mirror will be reflected according to the law of reflection. The angle of reflection is just equal to the angle of incidence. This behavior of the mirror in reflecting the light, whether you have a convex mirror or a concave mirror, this behavior of the mirror in reflecting the light, the incident light, may be used in ray diagrams. Ray diagrams are used to determine the location of the image. To a certain extent, we covered ray diagram, the concept of ray diagram, when we talked about plane mirror or flat mirror in the previous video. You might want to consider ray diagram for determining image location for a more complete picture on ray diagrams. Ray diagrams are typically used to check the results of your computations and analysis. So you might find this helpful after you have done your analysis. So you might want to consider ray diagram for determining image location as a reading assignment. Put simply, ray diagram traces the light rays and how these light rays are reflected or refracted in the case of lenses, reflected or refracted by the optical device to determine the location and orientation of the image. Here are a couple of figures showing how ray diagram is used to determine the image location and orientation. In this figure, you have a concave mirror. You have an object placed in front of the mirror. The object is considered as a light source. In particular, each point on the object may be considered as a light source. If we consider the top point of the object, that top point is emitting light or is considered to be emitting light in all directions. We consider two light rays. One light ray parallel to the center line. When it strikes the mirror, it gets focused towards the focal point. You have a converging mirror, a concave mirror. You have this reflected light. Another light ray directed towards the focal point. When it strikes the mirror, it is directed to become or reflected to become horizontal parallel to the center line. So you have two reflected light. You have one reflected light ray and another reflected light ray. The two light rays will intersect at this point. You have an image formed at this point. Doing the same thing for the other points on the object, you are able to form or determine the image. The image is located at the location of the reflected light. Thus, you have a real image. Comparing the two, the object and the image is upside down compared to the object. You have an inverted image. And of course, if you compare the sizes, the image is smaller than the object. You have an inverted real image that is smaller than the object. You can do the same thing with a convex mirror or diverging mirror. You have an object in front of the mirror. Consider the top point. The top point is considered to be a light source. Light rays are being emitted from that point. Two light rays. One light ray is parallel to the center line. You have a diverging mirror. This light ray will be directed or focused away from the focal point. You have another light ray directed towards the focal point. When it strikes the mirror, it is reflected and becomes parallel to the center line. You have two reflected light rays, one light ray and another light ray. They are not intersecting. Thus, in front of the mirror, you do not have any image formation. If we are to trace back the reflected light rays, the trace back line will intersect at this point, meaning you have image at this location. So do the same thing for other points on the object. You will be able to form the image. You have an image located behind the mirror. You have an image located where there are no reflected light. You have a virtual image. The image compared to the object, the image is upright or erect. You have an erect image. And the image is smaller than the object. So you have an erect virtual image that is smaller than the object. Now, note that these results are basically qualitative. But you may get a quantitative result or measurement if you draw the diagram to scale, meaning you use a ruler to measure the distances, the distance of the object, the distance of the focal point from the mirror, distance of the center point from the mirror, and so on. And to make sure that the angles, any angles that there are accurate, you use a protractor. So using a protractor and the ruler, you draw the diagram to scale, you'll be able to get a quantitative measurement of the image distance and height. But if you do it qualitatively, you'll just get an idea of basically where the image is, whether the image is inverted or upright or erect, whether the image is a real image or a virtual image. So, qualitative result. And that's it for now. That's it for our discussion on mirrors. We'll continue our discussion in the next video, wherein we continue our discussion on the topic of optics. In the next video, we take a look at image formation using lenses. So again, that's it for now, and thank you for watching.